Greetings. In this video, we will look at measures of position and outliers. So to start, let's look at z-scores. So a z-score is the distance from the mean in terms of standard deviation. So something to know about z-scores, they are unitless. So we won't need feet or inches or meters or anything like that. The mean for z-scores is 0, and the standard deviation among z-scores is 1. So z-scores come from what we call the standard normal distribution. So this is a bell-shaped distribution. Because the mean is 0, we know that it's centered at 0, and it has a standard deviation of 1. So remember that you know that standard deviations according to the empirical rule, tell us about the distribution of data values in a normal distribution. And so the z-scores follow this bell-shaped distribution. And so these scores are sometimes called a standard score because they can standardize values from other bell-shaped distributions. So the way that you standardize a value, if you know the mean and standard deviation from a distribution, like let's say that the mean is 100 and the standard deviation is 20, and we want to standardize a value of, let's say, 82. We can take the difference between the value and the mean. So in this case, well, first of all, I'll just write it as a formula. So we take the value and subtract the mean. So that's the difference. So when we're saying the distance from the mean, that's the distance. And then in terms of standard deviations, so we're then going to divide that by the standard deviation to figure out how many standard deviations this value is from the mean. For this particular example, that would be 82 minus 100 divided by 20. So 82 minus 100 is negative 18 over 20. And if we take negative 18 and divide it by 20, that's negative 0.9. So that's the z-score. It is the standardized score for this particular value of x. So it converts it from a value in this normal distribution to a value in this standard normal distribution. If we don't have population parameters, mu and sigma, you can also use x bar and s. So in that case, the formula, we would just replace mu and sigma with x bar and s, and the formula would look like this: z equals x minus x bar over s. So let me give you an example and show you why we would want to use standard scores. Let's say that we know that the heights in a population of men is 70 inches, and there's a standard deviation of 3 inches, and among the population of women, the mean height is 64 inches with a standard deviation of 4. So we have two people, there's a man and a woman. The man is 67 inches tall, the woman is 62 inches tall, and we want to know who is taller relative to their population. So this man relative to the population of all men, and this woman relative to the population of all women. So I know that just when I compare the two, that the man is taller than the woman, but I don't know if this is considered to be a tall man and this a tall woman or so forth. So I'm going to standardize these scores. So I'll use my formula z equals x minus mu over sigma. So for the man, so this is going to be z, I'm going to use a subscript of m here. This would be 67 minus the mean for that population, which is 70. And then in terms of the standard deviation for the population, for that population. So 67 minus 70 is negative 3 divided by 3. So this is negative 1. So that's the standardized or z-score for this man. it's -1. And for the woman, we have a z-score. I'll say this is for the woman. It is 62 minus the population mean for all women, which is 64, and the standard deviation among women, which is 4. So 62 minus 64 is -2. That's over 4. So that's -1/2. In other words, or -0.5. So the man has a z-score of -1, and the woman has a z-score of -1/2. So in terms of just, these are both standardized now. And so one of them is right here at -1. So this is the man, and then the woman is at -1/2. Let me just make this a little bit more obvious. Here is the gentleman, he's at -1, and here is the woman, she is at -1/2 in terms of a z-score. So in terms of z-scores, 0 would be the mean or the median. So notice that this score is to the right of this one. So if we're thinking along a number line, this is -1, -1/2, and 0. So 1/2 is greater, or -1/2 is greater than -1. It's to the right of -1. So this is larger than this value. So that would tell us that the woman is actually taller than relative to her population than the man is relative to his. So the woman who is 60 inches tall is relatively taller.